taking time out of your day to spend an hour with us. We truly appreciate it. Today we're going to go over migration to the Autodesk platform. A little bit about myself. I did a few years at the Ohio State University, and I am one of those that don't believe "the" belongs in there for controversy, but I am a licensed surveyor here in Ohio. I've been licensed since July of 1993. I spent 30 years in private practice and encompassing all kinds of civil and surveying projects. And then the last 13 years I've been here at IMAGINiT, focusing on civil engineering, surveying, and the migration of design platforms. So we're going to go over migration to Autodesk. And really, what does that mean? That means we're going to go from a Bentley platform to an Autodesk platform. And that kind of takes on a couple of really focused efforts, and we'll go over those today. So what is migration to Autodesk? It's really that framework that allows us to go from the Bentley platform to the Autodesk platform. I want to make sure that we take into consideration CAD standards and the utilities that have been created, and make sure that as we move not only the data from the Bentley platform, but we also move the functionality and the efficiencies that might have been custom created in that platform so they can be reproduced in the Autodesk platform. It's implementation plus a few things. The legacy standards, we have to take into consideration everything that was done over years, decades of drafting, and how that drafting will be translated over into the Autodesk or AutoCAD world. There are specific workflows that need to be followed. We want to make sure that we maintain those. Some may be done natively within the new Autodesk environment. Some of those workflows may have to be created and customized. Is there any automation that we can do? How do we do and translate large quantities of drawings and translate those DGNs into DWGs to be used within the Autodesk environment? Is there any data management considerations that need to be looked at? Do we have to create a data management system such as Autodesk Vault? Are we transferring data management from one system to another? Are they simply going to be a folder structure that needs to be maintained for projects with the information? And then how far back do we really go with the migration and conversion of legacy data? So IMAGINiT has over 100+ years of assisting customers with migrations from Bentley to Autodesk. And each engagement is really unique. Everybody has their own CAD standards that have to be translated, workflows specific to the projects that they're working on. And so every engagement is truly a unique engagement. So we want to make sure that it's reproducible. We want to follow best practices. And we also have some lessons learned that we've done over the years in doing this migration process. In the last year or so, we've really seen an increase in the request to go from a Bentley platform to the Autodesk platform. And so what we've done is we've really created a very formalized, structured service that allows us to efficiently move from the Bentley MicroStation to the Autodesk AutoCAD environment. So it really is a multi-phased process. It starts out with a discovery, and the discovery process is critical because during the discovery process, we really delineate the old CAD standards, and we really create that roadmap of how we're going to take those CAD standards and what they're going to look like on the new environment. And that, again, if we're doing any data management, we want to start from the beginning here in the discovery phase to understand how the files are used. Is the project folder structure? Is it a true data management system and how it's going to end up in the Autodesk environment. The next phase, we really focus on the migration and the translation. So the translation tables, every element that's going to be translated from the Bentley platform into the MicroStation platform. The seed file goes to the DWT template file. Want to make sure that we understand that and that we've got a clear roadmap for that. The development of the environment itself, you know, AutoCAD or Civil 3D does a lot of things natively, but did we come from an environment in MicroStation where we had customized utilities? This is where we're really going to map those out and have to recreate those utilities within the AutoCAD environment if necessary. And then again, the data management migration. Then there's an educational component. You know, we're going from Bentley MicroStation to AutoCAD. And so there's that learning curve from the drafting experience, lines, arcs, and circles, how we're going to utilize those now in the new environment. And so we need to train on that design software and understand that. If there's any custom workflows that have to be created, we need to train the individuals on those custom workflows. And then if it's a data management system from one system to another, there's an educational component within that. So if they're going to Autodesk Vault, for instance, then we have to make sure that we not only train the end users in Autodesk Vault, we need to train the administrators for Vault within that. So the educational component is a very, very important part of this process. And support. So support comes in many forms, in project mentoring, technical support, and e-learning or our Productivity Now portal. So in many cases, we actually do the discovery phase first as a separate component of the entire process. So it will be an actual standalone job service that we do. The reason this happens in large migrations, we really need to understand the magnitude of the translation of the files, the old CAD standards, and if there's any data management involved, because in order to write a comprehensive statement of work, we need that understanding. And so we will do the discovery phase first. There's a separate engagement, and then create that roadmap, and then write the statement of work to take the translation through the end. So again, the discovery, you know, it really focuses on the CAD standards and not just simply cells to blocks and line types and then levels to layers, but we have to really understand how the drawings and how those projects were put together. And in the discovery phase, we really want to look at how things were nested. And, you know, in MicroStation, how the files were nested and the complex nesting of those files. We have to understand, is that going to translate cleanly through, or are there structures, as we find in very large migrations, where the servers, there might encounter servers that no longer exist. So that server name is in a nesting, but it doesn't exist anymore. It's been changed, and things like that that have to be cleaned up along the way. So we really need to understand that clean slate and how to get everything over into the Autodesk environment. Any automation absolutely needs to be defined from the beginning. So we typically will tackle the automation first to make sure that those utilities will work in the Autodesk environment. And we may translate, you know, a handful of DGNs to DWGs that are necessary for macro utilities and things of that nature, so that we know that the programming is ready for the translation of the files. Same thing with the data management. We really want to, you know, start thinking about how we're going to set up and implement that new data management system, and again, run the test on the translated files and make sure that they will cleanly go into that environment, such as Vault, So a vault, nesting has to be a clean environment, and so the padding has to be correct for vault to accept that. So we want to make sure we correct those before we actually translate those drawings. And then the education needs to be defined. Typically, we don't do the education up front. We wait until we get down to the process and closer to the system being turned over for usage before we do the education, so that they can get some hands-on experience once we have the environment up and running. And again, sometimes during the discovery phase, we do this as a precursor to doing the entire translation and the actual implementation of the Autodesk platform. The data migration, again, we want to make sure that the new environment is created, and we want to base it on, moving forward with project structure. We want to make sure that we will encompass everything that a legacy environment for data migration was on either the Bentley platform, or it might even be another data management system within itself. We may do the translation and go into a non-Autodesk data management system, so we have to take into consideration those parameters too, if we were doing that and say we were going into Windchill or something along those lines. And so we want to make sure that all of that has been mapped out and tested. And then the migration of the legacy data, again, DGN to DWG. QAC is critical when we do the translations. So we make sure that as we go through the translation and create the translation tables, we're doing a QA/QC process of the DGNs to the DWGs. Visual checklists are created, visual inspection of the DGN to the DWG. Have the text types translated through cleanly? Are they the type text that we want to use in the new DWG format, and so forth? And that, we do have some problems with very, very old legacy MicroStation drawings where the text is not really string text. It is literally just a text element for the single character, and so we can handle that and work with those. The matrix is developed for the data translation, and that translation matrix controls everything when we do the process. Education, typically, there's always going to be that AutoCAD and education component, and that's, and lines, arcs, and circles, the drafting differences between MicroStation and AutoCAD. Want to make sure that those are clearly defined and that the training covers those, and that the end users are comfortable with the new platform. From there, we can build upon Civil 3D or Civil 3D Survey, depending on what they're going to be using, moving forward. From a data management, there's Vault, there's BIM 360. Are we going to go into an environment maybe with Autodesk building collaboration? So many options that way. We want to make sure that the training, again, not only for the end user, but for the administration people that'll handle the data management. And then there's also a data conversion education. So when everything is done, drawings turn up, especially on a large magnitude of a plant and so we want to make sure that the core group understands how to use the translator, how to use that translation table, so that down the road they can also convert data if found and as needed. So the roadmap to success. So I really have this broken down into a couple of categories, and the first one is what I consider a civil engineering, surveying, or architectural firm, and where they are and how we translate those functionality. And so the civil engineering to the surveying firm really is a methodology. So it's taking that design process and converting it over to the Autodesk platform and using the tools from Autodesk to do what they want to do, whether they're designing a road, whether they're doing surveying functions, topographic, alta surveys, whether they're an architectural firm designing buildings, doing MEP. That's a process that comes through. And so we want to match that process and then teach the new tools from the Autodesk perspective. Then we also have a large manufacturing facility or a government agency. And in that case, then we're really looking at translating a lot of legacy data. So there's the component of, okay, we're on a Bentley platform and we want to go to an AutoCAD platform. And so that can be mapped out, that automation can be created, and then that action item is complete. But there may be tens of thousands, hundreds of thousands of DGNs that have to be translated into DWG. And so that functionality has to happen. We have to educate the end users to use the new product that they're going to continue their projects in. And then from there, we have to make sure that they understand as things pop up. And by that, I mean from a manufacturing facility, then, you know, they have contractors out there that may say, oh, by the way, I have X amount of DGNs that we forgot to tell you about. And so now those have to be translated at a different date. We have to make sure that the organization understands how to translate those on their own, since all the translation tables have been built. So really, I consider these in those kind of two main buckets of categories for migrating from Bentley to Autodesk platform. And of course, the commonality of everything is it is MicroStation to AutoCAD. So DGN to DWG formats is really what it boils down to. So the engineering firms or the architectural firms. So again, I can't say it enough. We have to define their current CAD standards and their future CAD standards, and make sure that we translate those cleanly. So are they going from a very old Bentley standard of 1 to 64 levels? And are we taking those into the new, let's say, NCS CAD standards? And so in that discovery phase, that's where we define where we are and where we're going to go. And so once we have those CAD standards, they can be, from the drafting perspective of levels, they can be, and layers, they can be put into that translation table. The translation table really controls the major portions of the process. So levels to layers, cells to blocks. Line types is always one that causes problems in the translation, because the customization of a line type in MicroStation differs from the customization of the line type in AutoCAD. So the dashes, the dots, and things of that nature, those are straightforward and controlled by the line type scale. But as we have custom line types with characters and things of that nature, and those have to be recreated within the AutoCAD environment so that we can tell it to go from this custom line type A in MicroStation to this custom line type A in AutoCAD. And so those have to be done. Want to make sure that there's a seed file that contains the CAD standards, or most of the CAD standards that we have, and we will create a DWT file that has the CAD standards for AutoCAD. And so again, making sure that we cover everything that's going to be translated through there. Now once we build these translation tables, the way we do it is we'll have a folder structure, and we will run the translator through that. And so we want to make sure that we're getting the clean translation. Some items that we check for is uniformity of text. We have a routine that we can run that will check the text files and make sure that there's nothing that's very old and can be translated cleanly. The biggest thing that we do is we have a reference manager check that will go through and look and see how it's nested in going through for that. And so we make sure that those files don't contain unknown padding, and so we have to clean that padding up before that translation if that does exist for that. And so we use a reference manager tool for that. And then we also have another routine that will help us go through and look for drafting errors if needed, and so we can do that. Now again, from an engineering, surveying, architectural firm, it really is the functionality. So how do I recreate the workflows and manage those workflows? And so what we want to do is we want to take the workflow, look at the software that's appropriate, look at the native design functionality of that software, and adapt the workflows to best practices for the new platform. So we may take an older version of MicroStation and a design functionality of GeoPack or inroads along those lines, and then translate that into Civil 3D and the new platform of Civil 3D. How does it do the design functionality? You can see that once we go to that design functionality, that the training aspect is so important. And so when we move from one platform to the other, the first thing we're going to do is create those templates. And the reason we create the templates first is that's the foundation of success for moving off of one platform to a new design platform. Once those CAD standards are done in the template, then when anybody starts a new drawing, they're bringing those new CAD standards forward. And so that we want to make sure that if you are moving from one platform to the other, that we carry your brand forward. And so that brand is how your plans have looked. And a lot of organizations and firms have worked hard over years to create a brand, and we want to make sure that we carry that look forward with the consideration of things like, new true fonts and those kind of things. So once those CAD standards are developed, we know that it's going to be reproduced and created when the new platform, such as Civil 3D, is designing. Then we want to make sure that we address all the functionality that you had if you were doing sewer networks or pressure pipe networks. How does Civil 3D handle it, differing from coming off of something like Power Civil from there? And so we create those pipe networks and the styles that are associated with that. Civil 3D is a style-driven software, and so we want to make sure that all those styles are in there. And again, it's going to be developed on the best practices of the workflows to get you to the new platform. So from a engineering architectural point of view, we're not really translating a lot of drawings from that. We're translating the workflows that were done on the Bentley platform to the workflows that'll be done on the Autodesk platform. And for that, and then the end result is construction documents, and we need to consider that. How are the current plans being produced? We want to make sure that they're efficiently produced to the new construction documents in the new environment. And so how do those plans look? And so, ideally, when we migrate from a Bentley platform to an Autodesk platform, we are making sure that when you look at the paper version, the PDF version of what was created, that it is as close as possible. Sometimes we do encounter things that we can't recreate 100%, but we're usually in that 98th percentile of recreating the plans to carry those looks forward on that, for the construction documents. So as I said, the first thing we do is we really create the DWT, and that's the CAD standards. And so again, I've said it probably 5 times, levels to layers, line types to the new line types, cells to blocks, all the fundamentals of the CAD standards are held within the template, and that template allows us to move forward and recreate the look that we're looking for. Training is an absolute must within the new software. Want to make sure that everybody understands lines, arcs, and circles, how it's drafted, because you can't use the design functionality unless you can move around and do some basic drafting commands. So we always incorporate AutoCAD training whenever we move a firm off of one platform to the other. From there, we do the training on this specifics for their job. Are they civil engineering in the design functionality? So are we using Civil 3D for roads or grading or that type of functionality? Or are we doing surveying? We want to make sure that the surveyors are trained as well as everybody else for that. So training, again, is a critical component in the migration off of that Bentley platform. And then there's the implementation of the new software. And so you build the new template. So we've got the CAD standards covered. And then we train. And so now everybody's ready to take on a project. Now we have to implement that software. And for us in our services, we take that software and we help mentor through projects. And so the picks and clicks are different. Designing a road to the specifications of a municipality, that's the same. It doesn't matter which software you're doing it in, but the picks and clicks to do that software and the understanding of the software is really where we want to make sure that our clients understand what is necessary coming off of the platform. So we do provide mentoring for those new projects. Large manufacturing facilities, the same basic 3, but they present new problems. So the CAD standards for them typically go back decades. When we look at an engineering firm or an architectural firm, they may go back decades, but they're fairly straightforward in what they do. In large manufacturing facilities or large government facilities, then the CAD standards have kind of been diluted over the years, over the decades. Different programs may have come in and out of the manufacturing facilities, contractors in and out, different aspects. Data management, one of the things that we encounter in the large manufacturing facilities is their data management, maybe a homegrown data management system that is obsolete. And now we're going to take that into a new environment, typically an Autodesk Vault environment, or maybe another data management environment that we encounter, but we have to, roadmap and plan out how those files are going to go from the original data management system into a project folder structure and then into a new data management system. The CAD standards, again, probably the biggest thing you've heard me say is nesting and how that is. And nesting may cause a couple of things. It may cause a drawing not to translate. It may take a DGN and actually split it into multiple drawings upon that translation for that. One of the biggest things we have in going from MicroStation to AutoCAD is you have to remember that it's controlled by a translation table, and that translation is 1-to-1. So whatever is in that MicroStation drawing, it's going to be translated into that AutoCAD drawing, and it may be split up. That translation may cause it to create 2 AutoCAD drawings or 3 AutoCAD drawings, depending on the nesting within that DGN. So you have to be aware of that happening from that. And so when the DGNs are translated, the nesting is critical. The other thing that we found out is line types. The custom line types need to be made firsthand. The other question that we have is, well, can I translate my drawings and then go from paper space into model space? And the answer is no, not during the translation. Again, one-to-one translation. You can't make it do something that wasn't in one environment into the other environment. That being said, there are script routines that will, once that has happened, you can run those and it can create your paper space, model space. The other thing is borders. Want to make sure that whatever borders were created historically, that as we move forward, we've updated those borders and that are referenced in the AutoCAD version of borders. And so we can create that border and the title blocks for that, name it the same as the MicroStation borders. And then once it's translated, it's referenced into that drawing the same way it was referenced into the MicroStation drawing, but it's a new AutoCAD border. And so those borders can be referenced in. Again, not paper space, model space, but once those borders are in, you can run a script routine that will take that and put the model into model space and keep the border in the paper space. And so that's a common thing that we've done in these translation projects. Again, what's the purpose of the drawings, and how are they drafted, and how are the end users going to handle those for that, and what's the end result? Again, typically in a manufacturing facility, then we will have contractors using those. They'll be for additions, rehabilitation within the plant facilities, things of that nature. And so instead of being a final construction document per se, as an engineering or architectural firm will be, it may be for internal construction of that. So, typically PDFs are created and then plans aren't submitted to review agencies from that aspect. But still, you have to take into account the end result. So we can go and do the translation of these DWGs, but do the contractors and the employees of the facility, are they going to be viewing those in just a viewer? Do we need to create PDF plans, maybe through an automation, for hundreds of sheets and things of that nature? And so all of that needs to be taken into consideration. Again, the creation of the translation tables. So the translation tables, again, are a little more complex as we take into account multiple disciplines within a large manufacturing organization. There may be multiple verticals. There may be, an architectural and a civil and a mechanical and so forth that we have to take into account when we do these large manufacturing conversions for the plant plans in that. So translation tables typically are multiple tables that do that. We always want to test those translation tables. And so we will take a folder structure, a sample folder structure. We will run those translation tables through there. It is an iterative process because we always encounter things that are not handled by the translation tables. So as I said, every project is unique, and we find something a little different in every project that we do. And so we test the translation on a small scale, run it, QA/QC it, maybe a couple iterative processes till we feel it's comfortable with that, and then we'll do a large scale folder translation and go through the same process. Again, run it, QA/QC a percentage of those files for that, and make sure that the translation tables are handling that, and we'll do that in a discipline by discipline process if necessary for the translation tables. And so once we get through the QA/QC process and we're very comfortable with that, and our QA/QC process may be looking at hundreds of files and then using checklist so that we have documented proof on the translation, then we will translate all the legacy data from DGN to DWG, and then that will either be maintained in a project folder structure. If there's no data management, it may be uploaded into a data management system that is non-Autodesk, or it may be uploaded into Autodesk Vault or another data management system from Autodesk. And so we have to take into consideration all of that. And once we translate all of the files, we go through a final QA/QC and look at drawings and DWGs that have been translated from DGNs in multiple folders as a spot check, so that we just make sure that everything is good, that we're comfortable with all the translation. So a couple of current projects that we have going on, and I think it really will highlight why we've created this process. So from a plant environment, decades of microstation use. We've got a couple of plants, and you can see the magnitude of the DGNs that we've translated. So 70,000 DGNs to DWGs, 98,000 is a current project that we're working on for that, 25,000, which seems small in comparison to a couple of the others for that. And so that's why the QAQ process is so critical. We encounter so many different things in the nesting and in the drawing scales that differ from discipline to discipline within the manufacturing environment. So we have to make sure of that. We also have an ongoing project where we're doing a lot of automation. And again, those are tools that were created in the microstation environment, and now we are creating those same tools within the AutoCAD environment, so that from a production point of view, it'll be the same for the end users, and that they'll be able to accomplish their designs moving forward. From a civil engineering firm, again, civil engineering architectural firm, it really is about the process and how we designed before on the Bentley platform and how we're going to design on the Autodesk platform. And that boils back down to CAD standards and templates, education, and project mentoring. And so again, focusing on that, and we've got a number of engineering firms that we're moving from the Bentley platform over to the Civil 3D environment on the AutoCAD platform. So I left some time for questions. Hopefully there's a few questions out there that I can answer.
Everyone, go ahead and key your questions into the Q&A panel. And I'm not seeing any questions coming in, so that must mean that, Kevin, you answered all their questions with your fantastic presentation. Thank you.
Just as a quick wrap up, Gladys, you know, again, as we look back at this translation, the CAD standards and the defining of those CAD standards is the critical portion of any successful translation, and that translation can be done on a small scale, but it always includes a translation table, so old to new, for that, and defining each element within that translation. And then the difference between moving from a design perspective of engineering or architectural firms is all about learning the best practices of the new design platform. But we have to make sure that, one, we carry the CAD standards forward, two, we carry all the and create all the design functionality, from a civil 3D perspective, and in points and surfaces and grading and pipe networks and how they were done before, and training becomes that essential portion of allowing them to move off of one platform to the other. And then from a manufacturing large government perspective, it becomes all about the legacy data and how we move everything that they've done over decades from a DGN format to a DWG format, again passing through multiple translation tables. And this is where QA/QC becomes critical, because there's so many variables within there. You have to make sure that you are getting the quality pass through when you do the translation tables. And then it ends up with education, typically on their part, not only from the drafting point of view in the AutoCAD education, but from a data management point of view. So I'll kind of leave you with those few thoughts. And again, if you have any questions, please feel free to reach out to us, and we'll be more than happy to have a conversation with you.